what do you do if you contact your captain, you explain to them the situation, and you say you have to maneuver for contact C in particular, but for all of them, and they instruct you to stay on course but change speed. Now, the rules told you that a change of course alone is usually the best option. Doesn't say you have to do that, but it's usually the best option, and it is usually the best option. But they didn't say that you can't just change your speed. That's totally an option available to you. And for whatever reason, maybe that's the option you have to go with. What if, imagine, there's a lot of shoal water right here, or there's a lot of shoal water right here. You know, we had a new course at 293. What if turning to 293 is going to take you right at the shoal water or the reef or whatever it might be? And for whatever reason, it's too dangerous to come to starboard. In that case, if you wanted to pass the stern of contact C, you would have to reduce your speed. You can't change course over there. You have to reduce your speed. So, what do we do then? Well, let's go over to our contact, or a triangle for contact C. We still want the DRM to look like this. It's going to start at M3 and pass getting closest to us at 2 miles out, like that, meaning we still want our RM vector to be along this line. However, R prime can't come out to over here, because that only works if we come to 293 and maintain course. But any other change we make that's shorter, that's to the left of that, would involve reducing speed. You can see E to R for any of these points is smaller than it is to here. If we were to swing the arc around, our other option to maintain speed would involve something over here as our E to R vector. But anything between the two involves a shorter total speed. If we were to come out here, it's a higher speed. If you wanted to, if for whatever reason you wanted to increase speed to maneuver for them, but that's a terrible idea. Anything within here involves a reduction of speed. Now, this spot here involves a reduction of speed and a course change to the right. This spot here involves a reduction in speed and a course change to the left. But if you stay on course and only reduce speed, the only point where you can do that is right here. Luckily, when you plan a change in course, usually the consequences, you've already got your change in speed visible for you. You just have to pick it out. So if we set this point as our new R prime, I usually write R double prime to make that clear. It would involve staying on course, 255? Staying on course 255 and just reducing speed from 15 knots to whatever this speed is without ever changing course. And that will have the same effect on contact C. So let's see what that new speed would be. Remember, this is how far it goes in 6 minutes. So if we measure this out, we get 0.8 miles. 0.8 miles in 6 minutes gives us a new speed of 8 knots. So if we want to maneuver for contact C to pass astern of it at 2 miles, we could either change course to 293 and maintain 15 knots, or we could maintain course 255 and reduce speed to 8 knots. Both of them will have the same effect. And if there's shoal water to your starboard, you have to reduce speed. That's the only option you really have. You can't maneuver to starboard. You could also, of course, choose any other option here, but that would involve a change of course and speed, and there's no reason to make things more complicated for yourself. Usually you'll only ever be asked to change course and change speed. Remember, this as your new ER vector is going to have different impacts on contact B and contact A than this as our ER vector is. So now we have to go over and we have to see how that's going to affect the other contacts. So let's come to contact B here. Instead of changing course up to here and making this our ER vector, our ER vector is now going to be in the same direction as our original ER vector, but 0.8 miles long, marked like that. And we label it R double prime. And that is the ER vector if we reduce speed. Now we have to see what is that going to do for our relative motion. Well, we connect R double prime to M, and it's difficult because it's really crowded here, but it should look something like that. Then we slide our triangle to pass through M3 like we did before. And we get that. So now, if we were to change course to 293, contact B would head out this way. But if we were to stay on course and reduce speed to 8 knots, now it's going to head out this way. And that makes sense. Think about it. If we continue to go this way and they continue to go this way, but instead of us going faster than them, we now slow down to 8 knots and they're going faster to us, because I think they're going 6.9 knots. So they're not going faster than us, but they're still headed in this relationship between the two. Now they're going to pass ahead of us like this. Suddenly they're going to be overtaking us. Now what we just did there is we kind of screwed with the situation a lot. And I don't think contact B would appreciate us changing course instead of changing speed. This is definitely a less elegant solution, having it pass ahead of us like that. Still outside of our CPA limit, so that's fine. And this is part of why a changing course is probably preferable, but this does work. It doesn't create risk of collision. Now let's see what a reduction of speed to 8 knots would do for contact A. Let's see. There's our E to R double prime right there. When we place it on our original E to R line, because we're not changing course, we mark our double prime like that. There's our double prime. And now we connect the R double prime to M, and we see how that's going to impact our relative motion. So that's now our new relative motion if we were to change speed instead of changing course. And you can see doing that causes the CPA to come way into here. So a changing course in speed in this situation is not the correct solution. It's going to kill you. It's going to cause what looks like a 0.3 mile CPA with contact A. So while reducing speed will have the desired results for contact C, it will have very undesired results for contact A. Now that doesn't mean that it's always wrong. Sometimes reducing speed will be totally fine, especially if you only have one contact, then it's going to be mathematically identical. However, for contact A here, in this situation, staying on course and changing speed to 8 knots will create a close quarter situation with them, so it's not an option. Actually, before I end the video, I do want to make one note. All of these DRMs, while we changed their direction, we also changed their speed. Because if you look at contact A here, this was contact A's original R to M vector, meaning this was the speed of contact A's original R to M vector. This was its original speed, SRM, speed of relative motion. And that's what we used to calculate our time to CPA with them. However, if we were to change course and not speed, this would be their new RM vector. And that's parallel with the DRM that we chose for it to be. However, you can see the length now is longer, so the speed of relative motion in this case is increased, meaning the time to CPA is going to be based on the new CPA we get from this new DRM, if we were to measure that out, and calculated using the new SRM we got from this maneuver. So time to CPA is now completely thrown out the window. You have to recalculate all of that. Usually I mean, it's going to be required to you in your problems, but in reality, it's not something you need to worry about because your new time to CPA doesn't matter if your CPA is far enough away that it's not a concern. So it's not necessarily something we calculate all the time. However, if you wanted to, you could measure out what where the new CPA will be. Let's see, for contact C, the new CPA, if we maneuver correctly, will be right here. We could take the distance between M3, knowing that M3 occurs at 1515, and the CPA, and compare that distance to the SRM based on our course change. And that will give us our time to CPA for the new CPA. If we were to reduce speed, then this would be our SRM from R double prime to M, and it would be following the same DRM, but using a different speed. With the other contacts, because the DRM is either this or this for contact B, we would have new CPAs and new SRMs for both situations. So in any of these cases, you're going to have to do all the work to recalculate all of that. Or you could ignore it because you see that it's passing far enough away from you that it doesn't matter. However, technically, if you wanted to get all the necessary information, you would have to recalculate SRM and time to CPA for all of the new contacts.